In this video, we're going to talk about transformations of the exponential graph. So we just learned exponential graphs, and now how do we move them around? So we previously learned transformations using the square root function. We also did it with some parabolas as well. Basically, your graphs are going to move up and down, left and right. So let's graph these three functions on the same axis so we can kind of review what we learned. So first, we start off with our parent function, just the basic square root graph. If I put in 0, I get 0. Put in 1, I get 1. Put in 4, I get 2. All right, it kind of creates this little curve rising like that. All right, so that's f of x. All right, g of x has this plus 3 in the square root and this minus 4 out of here. Things in the square root move you left and right, and it's kind of annoying because it's at the opposite of which you see. Normally when we add, we go to the right. Here we're adding, we actually go to the left 3, and then we're going to go up and down based on this number. We're going to go down 4. 1, 2, 3, 4. All right, but then we have the exact same shape. So we'd have like a point there, point over 4 up 2, and we do the exact same shape as best as I can draw it, and I missed the dot, but whatever. All right, so it's the exact same red shape, slid left, and then down. Actually, I could even like do it like this. If I took this shape, I would literally slide it left, 1, 2, 3, slide it down, 1, 2, 3, 4. Actually did pretty good. But that would be basically what's happening. That exact shape is sliding around. Right. And then next, negative square root of x minus 2 plus 1. The numbers in here do the exact same thing. So I'm going to, in this case, this minus 2 is going to cause me to go right 2. Plus 1 is going to cause me to go up 1. So this is kind of my starting point. The only difference is this negative, instead of going up here, I'm going to go down and have a curve like that. All right, so it's still the same square root graph, it should stop there. I just took this graph, slid it, and then flipped it. I don't think I can do that with this. Let's see. So right 2, up 1, and nope, that doesn't do it. I tried. All right, but slid right, subto, then flips. All right, that's what that negative does. It flips it to go upside down instead of right. All right, so that's all you need to know about transformations. The things near the x, so in the square roots, it's kind of obvious because it's like wrapped in the square root. That's going to go left and right. The things away from the x, right, that happen after your function, that's going to move you up and down. And then the negative in front of your function just flips it to go the opposite direction, flips it up and down, not left and right. All right, for an exponential graph, this is what our transformations are going to look like. All right, the values near the x, these are going to be my left and right values, and the numbers away from the exponential, those are going to be my up and down values. All right, so let's see what this graph is going to look like. So our original kind of parent function is 2 to the x. We kind of ignore the other numbers. What would 2 to the x look like? It would have a horizontal asymptote. This is supposed to be dotted, but it's a lot quicker for me to just draw a flat line. All right, so it would have this asymptote here. It would have 0, 1, 1, 2, 4. All right, it levels off to the left and shoots off to the right. All right, so this is just 2 to the x. And what's going to be different with x minus 1 plus 1? All right, the minus 1 is going to take all these points and shift them left 1. All right, so now I have these points. And then this plus 1 is going to take everything and move it up 1. So now those points are going to go up 1, up 1, up 1. And my graph is going to look like, and all these points are going to go up 1, look like. So one important thing is you see this whole thing slid up. So our original horizontal asymptote is here. I have everything slid up, so the horizontal asymptote is also going to slide up. So I should also add a new horizontal asymptote. Oh gosh, I can't even draw a straight line. At 1. So this is really one of the most important things with the transformations for exponentials is the graph itself is moving, but also this horizontal asymptote moves. It doesn't matter on the left and right part, because if I slide this line to the left, it's still the same line. But when I slide it up and down, this line is going to move up as well. So in your final graph, you should have your horizontal asymptote in the right place and your general graph in the right place. All right, so here's same type of thing. 1/3 to the x is kind of our parent function. All right, that's going to kind of look like, just do it really, really light. It's going to look generally like that. And then what's going to happen, it's going to move to the left 3. So all these points are going to move to the left 3. And it's going to move down 2. All right, so it's really important. The first thing I'm going to add, I'm going to do it as a solid line. But again, when you're writing with a pencil, do it as a dotted line. We're going to have this horizontal asymptote at 2. Sorry, negative 2. All right, so that's my horizontal asymptote. That's where my graph is going to level off. And then the point 0, 1, move left 3, 1, 2, 3, down 2. So that's my kind of starting point now. Because that's where 0, 1 was, left 3, down 2. And now my graph levels off on the right and shoots up from there. All right, so that's my final graph. All right, again, it's kind of hard for me to draw these straight lines on the tablet. You can extend this along this horizontal asymptote, but this would be a good final graph. All right, one more, just that we add this negative sign. All right, not much is going to change. We start off with 2 to the x. I said 2 to the x, again, if I just do it really light, is low on the left, and then shoots up to the right. All right, but what's going to happen, it's going to move left 2, up 3. All right, so this point at 0, 1 is now going to be here at negative 2, 4. All right, the horizontal asymptote at 0 is also going to move up 3. Again, I'm going to put it as a solid line just because it's quicker, but it should be a dotted line. All right, that yellow is my horizontal asymptote. And then lastly, I had this negative sign. So now everything's going to flip upside down. So if my graph was originally going to want to look like this, all right, it's low here. Oops. Low here, and then shoot up there. Now I want to flip it. Now it's going to be on the other side of the asymptote. So this point's going to flip to there. And this is going to be my final graph. So basically I just take that horizontal asymptote as my kind of flipping point, and I flip it over top of that. All right, so here's one for you to try on your own. All right, go ahead and graph this exponential. I'll show you the answer in 3, 2, 1. So we have our horizontal asymptote at negative 3 because everything moved down 3. And then this point at 0, 1 got moved right 2, down 3 to there. And as it's 3, it's low on the left, high on the right. All right, close enough for what I'm getting. I want to see the moved horizontal asymptote and that it's going in the right direction. It's a quick summary. Numbers next to the x, so in our exponentials, they're going to be the numbers up in the exponent, go left and right. The numbers away from the x, which are kind of out here, go up and down. If I throw a negative inside in front of this, it just flips the graph. So instead of going like that, they're going to go like that. And for exponentials, always make sure you put your horizontal asymptote on your graph as well.